So does anybody have, and you can chat it to me, or you can go ahead and unmute yourself and just tell me what problem you'd like to see off the practice test if you have any. Does anybody have anything off the practice test besides those problems I've already done? I'll tell you again, I have done problems 2, 3, 4, 9, 11, and 12 on videos on either first period or third period, and they're already on the Canvas page. And whatever we do this period, I'm going to put on Canvas as well, so you can go back and look at that. Does anybody have any other questions you'd like to see on the practice test? And I'm getting nothing on my chats. Okay, so since nobody's got any other questions on the practice test, I want to know if you have anything off of the trail walk you would like to see. Does anybody have any problems off the trail walk? And I also want to make sure, because some of you weren't here, but number 6 had the wrong answer at the bottom on problem number 6 on the trail walk. It had something in parentheses to the third power, and it should be that thing in parentheses to the second power. It should have been a quadratic, not a cubic. So if that messed you up, you can fix that answer on number 6. At the bottom of the page, you should have said it to the second power. All right, I got number 8 on the trail walk. So I'm going to take a picture of that thing. I just had the trail walk, and now oh, it's over here. It's not it. All right, number 8. Okay, I'm going to take a picture here of number 8. And if you got more, if you got others you'd like to see, go ahead and chat those to me. And also, if you don't want everyone to know, feel free to hit that little arrow on the chat box, and you can do me private. You can do it with me privately, and then you don't have to worry about anybody else seeing who's asking the question if you're too shy. Okay, so there's the problem that you guys are wanting to see, or somebody's wanting to see. So I'm going to do that problem here in a second. I want to move something on my screen over a minute. Okay, so this problem is hope you all know it's a swim stroke, which means it's a square root problem. So I want to do a square root problem. So the parent function, and you do not need to do what I'm doing here with the parent function, but the parent function is y equals the square root of x. And the parent function is 0, 0 is a point, 1, 1 is a point, 4, 2 is a point. So the parent function looks something like that. So I guess we need to ask ourselves, how did these points move to take this point over to here? This point has moved from here down to here. What happened to make that point move from there to there? And if I look at this, it looks like to me that it went left 2, and it looks like it went down 1. So I want to see, did this point move the same way to get to here? So if I go left 1, 2, and down 1, it did. And if I take this one left 1, 2, and down 1, it moved the same. So all of the points from this red line have all moved left 2 and down 1. So what that means is there was a horizontal shift left 2. And this is how you describe it if it asks for you to describe it. And a vertical shift down 1. And by the way, that's a quotation, meaning it means the same as shift. Down 1. So we're supposed to know horizontal shifts go inside with the x, and they're opposite. So inside there with the x, since it's left 2, left is usually negative, but you must change the sign on horizontal, so we need a plus. and we need the 2 in there with it. And down 1 is that number out here all by itself, and those signs keep the same, and down is negative, and 1 would be -1. So that would be the equation of this function. And you would not have to put y there. You could put f of x, g of x, whatever you want. Y is fine, but that's how you would do that problem number 8. Anybody else have any problems you want to see off the trail walk or the practice test that I've not already recorded that I told you about? Or even off page 108. If you got anything off 108, we'll do that as well. We're going to turn all of that stuff in on Monday. If you were here Thursday, I think we already turned in the 108. Anybody got anything else? Page 108, number 71. Okay, I got to get my book and find problem number 71. I just have my book. Oh, I put it over here. All right. Okay, page 108, number 71 says, H is related to one of the parent functions described in this chapter. Identify the parent function. So we need to identify parent function. In other words, we have to name it. And that's something you'll have to do on the test. We need to describe the transformation. That is something you will have to do on the test. Probably a different problem than this one. Sketch the graph. You're going to have to graph something. Just like I did the last problem, kind of, but the opposite. We got to get the graph. And you do not have to do the last thing where you use the function notation, so I'm not going to do that on this problem. So number 71 says h of x equals x squared minus 9. So part A, describing the function, means that we want to look at this part. There is one of our parent functions that has that in it, and that is called a quadratic. So we would call this a quadratic. That is the parent function, a quadratic function. Then the quadratic function, maybe I should erase this part. A quadratic function, the parent function, and you don't need to write this down, is y equals x squared. So the question that you need to ask yourself is, how is this x squared minus 9 different than x squared? So the way that it's different is it has a minus 9. Now, is that in parentheses with the x? And I hope we would say no, it's out there all by itself. So there's only one difference, that minus 9, so we only have one description. So we should call this a vertical shift. Now you can abbreviate vertical with V, but you can't abbreviate shift because there's also shrinks and stretches. So this is a vertical shift down 9. So there's the description. Part C is graph it. Well, this is the parent function. And you are supposed to know the parent function. And some of you do. I hope all of you do, but I'm not sure that you all do. So if I were to graph this function, and I'm talking about just the regular x squared, I'm not graphing the one that's going to be worth points. And on the test, you are not, unless it tells you to, you are not supposed to graph the parent function. So you can graph this parent function by doing a t-chart or typing it into your calculator. So it goes through 0, 0, 1, 1, 2, 4, 3, 9, and that's from a t-chart, or I already know these. I know it goes up 1 over 1, then up 3 over 1, then up 5 over 1, up 7 over 1. And it keeps that pattern going forever. So this is the parent function. This is not the answer. This is not the answer to your problem. This is what the parent function looks like. Now this description tells us what to do with all these points. So this says vertical shift down 9. So what that means is when we graph this 0, 0 point is moved down 1, 2, 3, 4, 5, 6, 7, 8, 9. So down here at -9, we have a dot right here. This point that's at 1, 1 is moved down 9. That's going to put that point at 1, -8. This point over here that was at -1, 1 is moved down 9. That's going to put it at -1, 8. The point that is at 2, 4 will be moved down 9. So that's going to put that point at 2, -5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I got to go over another spot. And if you have another point up here, if there's a point up here that's at 3, 9 and -3, 9. So if I move those down 9, that's where the function is going to cross the x-axis at -3 and 3. So that would be enough points to graph this pretty well. So this red on the graph is what I will be looking for. You're not supposed to put the original parent function on there. You're just supposed to put this transformation. Does anybody else have any, oh, and number 12, practice test 9 and 12. Okay, well, I've already said this. Maybe you came late to the meeting. 9 and 12 are already done on video in one of the other classes. So if you go to my Canvas page, you can go to period 1, and I've got all the problems that were worked out there, and period 3, and all of the problems that were worked out there, and you can go right there and see those problems. Now, if you look at those problems and don't know how to do them, then you should send me another email, and I will Zoom with you one-on-one and explain to you how to do them. But they have been done in quite a bit of detail when I did them the first time. Unless we don't have other questions, I can do them again for you, but I'm going to wait and see because I'd rather do all the things I have not already put on video. And that, like I said, they are already on my Canvas page, and they are on for today's lesson 9/11. So you go to Friday. If you go to the right side of that daily assignments for 9/11, you go to the right side, they're right there in order. And I'm going to put this video right under those. Does anybody have any other problems that I haven't already told you I've done? Off page 108, off the trail walk, off the practice test. Okay, since there are no other questions, I'm going to go ahead and show you 9 and 12 again because get your money's worth. So we're going to come over here and we're going to go to number 9 on the practice test, which is right here. And you're supposed to know that the parent function for this is y equals the cube root of x. So you're supposed to already know that the cube root of x goes through 0, 0, 1, 1, 8, 2, and all I'm really doing here is doing a t-chart. I am basically plugging these numbers in for x, and when you take the cube root of these, you get out these answers. And also -1, -1, and -8, -2. Now I have these memorized, and you should be getting pretty close to that, but this is disco left, disco right. That right there is the parent function. Now we are supposed to describe these. Now from this equation down here, there are two things different. There's a +2 inside and a +2 outside. So the inside is a horizontal shift. So you need to say H for horizontal, and you must write out shift because there's shrinks and stretches. Horizontal shift left 2 because you go the opposite way of the sign with the X. And then there is a vertical shift down, or sorry, that's +2, so up 2. Vertical shifts go the same way as a sign. So I'm going to come over here, and I'm going to take these points that I just had for you, and I'm going to shift them all to the left. Oops, I didn't put 2. Left 2 and up 2. So I'm going to take this -8, -2, and go left 2 and up 2, which puts it at -10 on the x-axis. So that point would shift to here. This is going to be this graph. -1, -1, I'm going to go left 2, up 2. That's going to put that graph at -3, 1. So I go to -3, 1. Then I take this point at 0, 0. I go left 2, up 2. That's going to be at -1. Let's see, I said left 2. That's going to be at -2, 2. And 1, 1 is going to go left 2, up 2. So that's going to be at -1, 3. And then this 8, 2, if I go left 2, that's 6, and up 2 is 4. So 6, 4. And then I'm going to draw this graph just like I did the other one. They should look identical, just moved left 2 and up 2. Number 12 says find the inverse. I've done this in class many times. I don't know why they put a parenthesis here, but they did. Step 1, change f of x into y. I'm not going to put the parenthesis there. I'm just going to write it like that. Same thing. Step 2, switch your x and your y around. Step 3 is we are going to solve this. We're going to solve this for y. So I need to subtract 1 from both sides. Now, the fastest way to get rid of a fraction is multiply by the reciprocal. So I am now going to multiply this side by 3 over 2. And I'm going to multiply this side by 3 over 2. That's the fastest way to get rid of a fraction. So those 3's reduce, those 2's reduce to 1's. So that leaves me with a y over here. And you can distribute 3 halves in there, or you can leave 3 halves out in front. I'm just going to leave it out in front. And then step 4 is change this y back into inverse notation. So this would be your inverse equation. And if you want to distribute that 3 halves in there, you could write this like this, and that's fine. Or you could even look here and say, hey, I have common denominators. You could write it like this and be fine. This would be the same equation. Okay? Does anybody have anything else you would like to see? Anything else? Again, we had the test on Monday, Tuesday. Wednesday and Thursday, we're starting Chapter 2, Unit 2, Section 1. And I've got a picture of the book in the canvas, but I have not done a video. I'm planning on doing a video after this on how to do Section 2.1. And then I'm going to post it on on Wednesday screen for next week, because that'll be the day you do it. You ought to watch that before you come to class Wednesday. And I got Khan Academy assignments in there that go along with that test. Not the test, but along with those assignments. I got 2 Khan Academies, and that's what you're doing Friday. Anybody got any more questions on the test? Test is, it's over 2 sections, 1.7 and 1.9, transformations and inverses. Okay, then I'm going to sign off. I hope you guys have a great weekend. Stay out of trouble. Do what's right, not what's popular. And I will see you all on Monday and Tuesday of next week. Have a great weekend.